Hi, this is Andreas from DevNet Expert Training. In this video, I will introduce you to the Yang language and how we can use it to represent a data model for structured data. Let's begin with understanding the problem Yang tries to solve. Imagine that a coworker of yours asks you details about how they should configure a network device. They want to do the implementation, but need specific instructions about the requirements. In this example, we will imagine a layer 2 switch with multiple VLANs and switch port interfaces. You will need to express the desired configuration in a way both of you understand. Now, to write your instructions, you can start with a blank sheet of paper and begin to create either a diagram or reference specific points in the documentation, or even write down configuration commands so your coworker can know exactly what the configuration should look like. There are literally hundreds of different methods that you can use to describe the intended configuration, and many of them can lead to misunderstandings or unintended missing information. This isn't very effective, and especially not when we deal with automation. So what if there was a standard form that you could fill out instead? With fixed fields and checkboxes? This would make it much easier to express the desired configuration, because a form like that works as a data model that enables a common understanding between both parties. Now, let's change the parties here to be pieces of software instead of human beings. On one side, you have the network device that needs to be configured, and on the other side, you have some automation tool that interacts with the device and deploys the configuration. The common language between these two ends of the connection is called Yang. It's an abbreviation of yet another next generation. Yang is a data modeling language that is described in RFC 6020. This RFC is actually quite readable and gives a lot of examples on how to express various data structures as a model. When considering Yang and what it can be used for, we need to realize that the concept itself is quite abstract, because Yang is just a language that is used to describe a data model. This data model could represent basically anything, but usually it relates to network device configuration and state data. To step down from the abstract concept of a modeling language all the way to actual network equipment, we need to pass through some other components along the path. We use Yang to create modules, which are individual source code files that are combined into one larger data model. When data that follows this Yang model is serialized into a human-readable format, it will be represented as XML or JSON documents. This document could describe anything network-related, like a BGP configuration or interface counters or access control lists that are supported and understood by the network device. The Yang language itself knows nothing about networking, as it only defines the syntax to describe an arbitrary data model. The model itself could be defined by vendors, standard bodies, or even yourself. The logical trace you need to make to get from Yang to actual device configuration looks like this. It all starts with the Yang data modeling language, which doesn't know anything about networking or device configuration or protocols. The language is human readable and uses a syntax similar to programming languages, with curly brackets, indentation, semicolons, quotes, and other familiar coding symbols. Each vendor and standard body then defines their own model using the Yang language. You can think of these models as a kind of template that you need to comply with to write configuration that the device would understand, like the form we talked about before. A Yang model is made up of multiple Yang modules, which are the .yang files. When you have found the correct model to describe your configuration, you can create an XML or JSON document that complies with the model. Think of the model as a template and the XML document as the actual configuration data. Very similar to when you do CLI configuration of a router, you can use the context-sensitive help with the question mark on the command line of iOS, and the router will inform you about the syntax, but you need to provide the actual values for the configuration. To apply the configuration to the device, we need a management protocol. We can't open a telnet or SSH connection to a router and just start pasting XML or JSON in there. If our document is XML based, we will be using netconf, and if it's JSON, we will be using restconf. Netconf will use a special SSH connection on TCP port 830, and we need a netconf client to encapsulate the document correctly into multiple layers of XML tags. RESTconf, on the other hand, will use an HTTPS connection on TCP port 443, and we can interact with it using an HTTP client like Postman, curl, or even a web browser. You can read more about the inner workings of netconf and restconf in the articles on my website. Links are in the description below. In the end, the configuration will be sent to the device and applied to the configuration. After the configuration has been applied, it will no longer be represented by XML or JSON. You can see the result as regular CLI commands in the running configuration on the device. Let's have a look at the Yang models for Cisco IOS XE and NXOS. They are publicly available in multiple places, including the GitHub repository called Yang models. Let's navigate to Vendors, Cisco, XE, and version 17.51. In here you see a lot of files, each representing an iOS feature with its own Yang module. These are combinations of standard Yang modules, like you see down here, with the OpenConfig and IETF modules. And we also have vendor-specific models up here, represented by the Cisco IOS XE-something.yang modules. If we take a look inside one of these files, we can see the Yang language being used. These files very quickly become large and unmanageable. So we need some tool to handle them efficiently. Let's clone the repository and use the PyYang CLI tool to interpret the Yang model for NXOS. Let's go into the Yang repository, into Vendors, Cisco, and let's have a look into NXOS. So the modules for NXOS is slightly different from iOS XE because it only has this single Cisco NXOS device Yang module, which is pretty large. So that is very different from the iOS XE modules that we saw before, where we have just one module file for each feature on iOS XE. So let's try to render the model here. With the PyYang tool, we can use the -F for format and format it as a tree. So the output here is pretty interesting. It's also huge. So what this is actually showing us is the hierarchy of the Yang model inside of NXOS. So it all begins in the root with the system container here, and then we have a lot of different Yang leaves and properties and configuration below it. So this is a lot of lines. Let's just actually pipe this one into our counter to see how many lines exactly. You see the output here is more than 37,000 lines. So it's actually not a good place to start because it's so complex. So let's just try to create our own Yang model representing a simple switch with only a few Yang nodes inside of it. Now we will create our own custom Yang model to better understand some of the common Yang statements that we may find in real vendor models or standard models. In this example, we are going to describe some configuration and properties of a simple layer 2 switch and basic switch port configuration. Every Yang module needs a .yang file with the same name as the module. I'll call my new module Ethernet switch. So my file name needs to be ethernetswitch.yang. This module keyword is our very first Yang statement. Everything we declare with Yang is considered statements. That goes for the entire schema consisting of data nodes and non-data nodes, as well as metadata and other properties. The only two statements that are mandatory for a module are the namespace and prefix statements. A namespace uniquely identifies this specific module and is expressed as a URL. You see, I may not be the first person in the world to invent a Yang model that describes an Ethernet switch and choose this name for the module. So I need to add this piece of metadata to ensure my module is absolutely unique. Because a Yang model can consist of multiple modules, which in many cases imports and augments each other, I also need to assign a prefix to my local module so it can be accessed and reused by other modules. Now that I have written an absolute minimum of code with just the required statements, it's time to validate my new model. I will use the Pyang CLI tool again. Because my model doesn't really contain any schema nodes yet, I just get an empty output. But this empty output also tells me that at least the file is valid so far. I'll use the watch command for Linux here to just continuously validate my model, and then we can see the output as we start to add more statements. The first data node that I will add to the schema is the most basic of the Yang data node types. It's called a leaf, and it can hold one single symbol value. All data nodes in Yang take one argument, which is the identifier. In my case, I'll define a host name and the type will be string. I also want my switch to have some Ethernet interfaces. Because I'm just describing the data model and not any specific switch model, I don't know how many interfaces it will have. So it would not make sense to create separate leaf statements like this for Ethernet 1, Ethernet 2, and Ethernet 3, and so on. Instead, I can use the leaf list Yang statement. This allows the data node to be present multiple times. The asterisk after the node identifier indicates that this is a leaf list. The question mark after the host name node here means that this node is optional. It's perfectly valid to put in the host name in our XML document, but we can also leave it out. Both cases would be fine because this is not a mandatory node. A Yang model isn't much fun if you don't use it to access or define some data. So let's create an XML document. This XML document will represent a specific switch with specific configuration. All XML documents begin with an XML declaration as the header. This has always been required by the XML standard and has been like this for decades, long before there were anything called Yang. So let's just accept that for now. We don't need to spend a lot of time on it. The interesting thing is the root data element. We'll use this as a placeholder for the schema nodes defined in the Yang model. Inside of this, I can define the host name and a couple of interfaces. Now, if I wanted to validate this XML document against my Yang model, I can use something like the Yang to DSDL tool. It can take my two files as input and look for any errors. So let me just enter split screen here for my files so we can compare them and also have the Yang to DSDL tool running and continuously validating my XML document towards the Yang model. If I just do this now, I would expect some errors regarding namespace. Let's try. Yes, you see namespace error. Expecting a namespace for element data. This is the root object here. The root data element needs a very specific namespace defined by netconf. Actually, Yang to DSDL will tell exactly what we need if I just add in some random string as the XML namespace for that element. You see, it tells us exactly what we need right here. So let's add that in as the XML namespace. Now we get another error, this time on line 3, saying that the host name is considered an extra element. This is because I haven't specified that these XML elements are supposed to be mapped to the Yang model with this exact namespace. So let's do that as well. I will have to add the namespace to each of the elements that are contained directly under the data root element. You see, now it changed to no errors found. And that's about the most positive message we can expect from the Yang to DSDL tool, that it didn't found any errors. If I added more elements inside of the root data element of the XML document here, like the management IP, then I would have to add in the XML namespace for that as well and map it to my Yang model over here. So to avoid doing this for every element that we add inside of the data root, we could use a container to wrap all of these as one single group and then only define the namespace on the group level. So let's try to create a container for that. I'll call the container switch in this case. You see, now the model here is starting to look more hierarchical, but we did get an error now because we need to adjust the XML data as well. This is where I put in the XML namespace, and I can remove it from the other elements after that. So now we have a valid document again. Now we should expand the model to hold more data about the interfaces than just their names. If we change the Yang leaf list to a Yang list statement, we can treat it like a Yang container and nest other schema nodes inside of it, like the interface name, a description, and the Ethernet interface speed. PyYang now tells us that the list needs at least one key, and that means that the list up here needs to choose one of the leaves inside of it to be the unique identifier for that specific list item. So let's choose the name in this case, because every switch port name will be different. So the error went away, and we can see that our interface here has now changed. Instead of just having an asterisk, we also see the square brackets over here with the key inside of it, and this tells us that we're dealing with a list and not just a leaf list. Inside of it, we then see the name, the description, and the speed. And note how name does not have a question mark. It means that it's now mandatory to put it in because we use it as the key. I need to update the interface elements in my XML document to represent the new structure. So I'll be adding in a separate element for name inside each of these two interfaces. And now the document is valid again. Now that I have talked about leaf lists, leaves, containers, and lists, let's take a step back and have a look at how you may interpret these different data node types. The following explanation will assume that you have experience with Python structures like lists, dictionaries, and classes. I will use those terms to compare and understand Yang data nodes. In Yang, we can divide the data node types into categories on two different levels. Some Yang data nodes represent only one symbol value. Other may contain a nested hierarchy of child nodes and act as a group for these nodes. On the other hand, some data nodes represent a single instance, meaning that only one instance in the XML document is allowed. Other nodes represent multiple instances, meaning that any number of instances of the XML element is allowed. So for each combination of these features, there's an appropriate Yang data node type. Let's try to compare them with similar data structures in Python. A single node with just one symbol value is a Yang leaf. The actual data type can vary, and it may be an integer, string, boolean, or something else. The blue words in this table are Yang statements, and the red words are Python equivalents. Multiple instances of one symbol value is a leaf list in Yang, and it is comparable with a list in Python. All values in the list must be of the same type. To create a group of values or even a nested hierarchy in Python, we can define a class with various properties. Each property can be of different data types and are completely independent. A similar concept in Yang is the container. You would often use this to introduce a new level in the module to group values hierarchically. Now, if we want to represent multiple instances of a more complex schema in Yang, we need to use the list statement. Note how the word list sounds very simple and that you could easily mistake this Yang statement for something that is similar to a Python list. This is not the case. It is actually more like a Python dictionary that contains classes or objects for each dictionary element. So for each entry in the Yang list, we need a key, just like we do with the dictionary in Python. If you can remember this table, it will be a lot easier to interpret the data nodes of a Yang model. Now let's continue building the Ethernet switch Yang model. For strings, there are some formatting restrictions that we could make use of in our model. Maybe we want to ensure that the switch interface names always contain the word Ethernet 0/something. We can use a regular expression as a pattern to restrict the values accepted by the model. Instead of ending the type statement in a semicolon, we open a new block to add some properties to it. In this case, I put in the regular expression to match any type of Ethernet interface in the first module 0 of the physical switch. Be aware that you don't need to know about an advanced regular expression syntax for the DevNet Expert blueprint. It is not mentioned anywhere in the blueprint at all, so you shouldn't expect to see it there. Let's do another formatting restriction for the interface description. This time I want to ensure a meaningful description is provided, so I will ensure the length of the string is between 4 and 50 characters. These numbers may not make sense in all cases, but remember that this is just an example of what we can do with Yang. Now we get some validation errors from Yang to DSDL regarding the name element, because it doesn't adhere to the string pattern that we just created. So let's change that to make sure that this is Ethernet 0/1 and Ethernet 0/2 instead. Actually, this could be fast Ethernet and the other one could be gigabit Ethernet. Now the speed leaf here is an unsigned integer, but we didn't really talk about the number it represents. Is it bits per second or gigabytes per minute? Let's make this clear and add the units property and specify that we mean megabits per second here. While we are here, we can also consider making this a read-only leaf, since the maximum speed is a physical characteristic and not something we can change through configuration on this particular switch model. We do this by setting the config property to false. You can then see that the label next to the speed leaf here changes from RW to RO, which means read-only instead of read-write. You may notice that some of the other properties that I put into the model, like the units and the length, doesn't really appear in the rendered Yang model with the Pyang tool. This doesn't mean that they aren't there, but this is simply a limitation of the Pyang CLI tool. Let's add a description to our interfaces. We are now receiving some validation errors because the description is only 3 characters instead of the 4 that we specified as a minimum over here. So let's change that and see that our document is now valid again. Let's add some more configuration data to this model. A layer 2 switch port can be either access or trunk. This is usually referred to as the switch port mode. Because we want to limit the input to allow only 2 specific values, access and trunk, this is a good opportunity to use the enumeration type. Each valid input is listed with the enum statement. If we provide any other value inside the corresponding XML element, the validation will fail. So access is good, trunk is good. Let's try to change it to something else. We should now see a validation failure with Yang to DSDL. So let's change this one back to trunk. The point here is that a Yang validator can do all the heavy lifting regarding input validation for you to make the application and device management much more consistent. Access ports on a layer 2 switch support just one single VLAN, and trunk ports support a list of allowed VLANs on the trunk. Because a switch port can't be access and trunk at the same time, it would make sense to define this with a Yang choice statement. A choice contains multiple cases where only one of them is allowed to be present in the XML document. We will define a case for each switch port mode, and their data node type will be different. So the node for access VLAN will be a Yang leaf and of type integer, and trunked VLANs will be a leaf list, also of type integer. We can add some numeric restrictions here as well and ensure that the number values are between 1 and 4094. Even though choice and case statements are nodes inside of the Yang schema, they do behave differently because they are non-data nodes. We can see this information in the RFC about these statements, but in fact Pyang will also let us know by displaying these nodes in parentheses like you see down here for access or trunk or access. This means that choice and case nodes are not allowed in actual XML documents. They define only the possible structure of multiple segregated and incompatible nodes. Like in our example with the Ethernet switch port, it would make sense to ensure that mode access is mutually exclusive with trunked VLANs. So my point here is that we are not allowed to create an element in here with the tag access or trunk with some trunk beneath it. This is not needed because these are in parentheses, which means that they are non-data nodes. So directly on the same level as the name, description, speed, mode, we can then put in the access VLAN or the trunk VLANs because we can ignore any node that is put in parentheses by the Pyang output here, which means that it is non-data nodes. So let's just go back here and just add the access VLAN. The choice we then make in the XML documents are only locally significant to each entry in our interface list. So it's perfectly fine to use trunked VLANs on one interface and access VLAN on the other one, but we cannot combine them. This results in a validation error. In our Yang model here, there is still a possibility for creating some inconsistency because the switch port mode is defined outside of the choice, and we haven't made any effort to tie these two nodes together. So the case that was chosen for the choice down here doesn't relate to the mode at all. So actually I could change this one to trunk and the other one to access, and according to Yang this would still be perfectly valid, even though from a networking point of view it doesn't really make any sense to talk about multiple trunked VLANs on an access port. So let's add a condition in the form of a when statement to ensure that this doesn't happen. So I will only allow the leaf with the identifier access VLAN in the case where the mode equals to access. And I will only allow the case trunk when the mode equals to trunk. So I get the validation error now that it found a node that are only valid when the mode equals to access. So this is because right now we have the inconsistency that I talked about before. So let's change the mode to access in the case where we have the access VLAN, and we'll change the mode to trunk in the case where we have the list of trunk VLANs, and now we get no errors found. This identifier over here is a path in the Yang model. So right now we are comparing two nodes that are on the same level in the schema hierarchy, and we can then just use the identifier for that leaf. But in the case with a more hierarchical structure in our Yang model, I would need to use the dot, dot, and slash notations, just like if you were navigating a file system. So something like this would also be valid syntax if we had a hierarchy that looked kind of like that. But we're just comparing something on the same level here, so let's just keep it simple. There are a couple of type-related Yang features I would like to introduce you to before I end this demonstration. The first one is the possibility of creating your own custom type definition. Until now, we have just used strings and different types of integers. You see how I use the same data type and range property in both cases where I expected a VLAN number. To not repeat myself and make the model a bit more readable, I can use the typedef statement up here in the root of my module. So I just created a new type with the identifier VLAN ID with the same settings regarding the VLAN number range. This makes it possible to use that type any number of times inside of my model by simply changing the node type to VLAN ID. Now, if you are used to working with switchboard trunks, you know that we usually specify a range of VLANs using a dash syntax. For instance, 10-19 means that it would also include all the VLANs in that range. To support a VLAN range at our trunked VLAN data node in the Yang model, we need a string. I will create a simple pattern to match the string format. This regular expression allows two numbers with a dash in between. It isn't perfect for the job, but it serves well for the demonstration, so let's just keep it simple. Now, in many cases, we combine VLAN ranges with individual VLANs on the list of allowed VLANs on a trunk. So this leads me to the last type-related feature I wanted to show you. I'm talking about the union statement. This allows a data node to be represented by multiple distinct values in the same place in the hierarchy. So inside the union statement, I can start listing all the valid types for this data node. So let's just add in the two different types we have worked with previously. And I can then have multiple different types inside of it. So both a string that adheres to this format is allowed, just like our VLAN range over here, and also the custom VLAN ID type definition is allowed at the same time. You see now that Yang is the language we use to agree about the data model for configuration or state data that we are working with on network devices. I hope you enjoyed this video. As the next step, I will recommend you go and have a look at the real Yang modules in the repository on GitHub. Find a module that relates to a networking feature you know well and try to read through the Yang model to understand the data model, and maybe try to render it with PyYang or create your own XML document to represent the configuration.